Hello and welcome to Unit 4 of Week 1 of the openSAP course SAP Leonardo IoT for the Intelligent Enterprise. In this unit, we are going to talk about a customer project we are doing with the city of Heidelberg. It is about smart waste management. This project stands as an example and shows how IoT projects often involve several strong partners to make it a success. My name is Frank Rambo and I'm a product owner for Leonardo IoT. And I'm very excited to have next to me Michael Bozek. Michael is a business developer working for Pepper & Fuchs, a manufacturer of sensor hardware SAP is partnering with. Heidelberg is a city in Germany and has a population of about 160,000. It is a very historical and romantic city with a castle and a river. It's getting quite some attention from visitors from all over the world. Besides that, Heidelberg is also has a well-known university. In 2017, the city of Heidelberg started a journey to transform into a smart city. For that purpose, the Digitalagentur Heidelberg, or Digital Agency Heidelberg, was founded. The responsibility of the Digitalagentur Heidelberg is to drive Heidelberg's transformation into a smart city. One of their goals is to consolidate all IoT data into a single scalable IoT platform which easily integrates with other cloud and on-premise systems. Before the project was kicked off, the Digitalagentur conducted a design thinking workshop at the SAP App House in Heidelberg, which was facilitated by SAP Digital Business Services. Several smart city use cases were discussed and evaluated. As a result, the Digitalagentur Heidelberg decided to kick off a pilot project with the topic of smart waste management. The idea was to equip recycling containers for glass deployed in public areas with sensors to measure fill level, temperature and geolocation and send the data via long-range or LoRa wide area network to the SAP cloud where it was consumed and acted upon by an SAP Leonardo IoT application. This would turn a previously rather manual and paper-based process into a more automated routing of the glass collection vehicles based on recent fill level information from the sensors. This saves time, reduces cost, noise, exhaust emissions and traffic impact from glass collection vehicles. Now, what does it take to turn glass collection from recycling containers smarter? Well, it obviously starts all with the glass, empty bottles and other glassware. Then there are the recycling containers, and there are roughly 300 of them deployed across the city of Heidelberg. The next thing is very important. It only works through the discipline of the Heidelberg citizens who collect their glass at home and throw it from time to time in the containers or into the containers. So if you are Heidelberg citizens, we'll count on you. Next, we'll need a robust sensor measuring fill level of glass inside the containers and maybe a few other things like temperature and geolocation. It needs to be an industrial sensor that is autonomous with long battery lifetimes, and it needs to withstand outdoor conditions. Think of temperature range during winter and summertime, for example. We need to mount these sensors into the containers that are already in use. And we need to do this in a way that the sensors can't be damaged when people throw in bottles or when the containers are lifted up during emptying. Then we need the sensors to send its data through a cost-efficient network to ingest it into SAP Cloud Platform. And once the sensor data is in the cloud, it's not enough just to store and visualize the data. We also want to respond to the data and act upon it. For example, when a sensor is telling us that a recycling container is full and needs to be emptied. Typically, there are already business systems in place which plan and control the routes of the glass collection vehicles, and we don't want to reinvent the wheel here. What we want instead is our cloud application to integrate with the business systems that does that. And that's key. IoT is not about dashboarding sensor data. It's really about turning business processes smarter or enabling entirely new business processes. So these are our ingredients for smart waste management: waste, recycling containers, the Heidelberg citizens, industrial sensors, a network, and a cloud solution that integrates with existing business processes. Let's look into each of them in a bit more detail. Recycling containers are first, so let's talk first of them. Before you can start mounting sensors into recycling containers, it's important to remember that the containers are owned by somebody you need to get permission from. The recycling containers in Heidelberg are owned by a large global service provider for recycling and water management. Alone in Germany, they own and operate several recycling facilities for glass and also a fleet of roughly 100,000 glass containers deployed all across the country, which makes them one of the largest players in this business. They also service most of their containers in terms of collecting the glass from the containers and shipping them to one of their recycling facilities. However, in the case of Heidelberg, they contracted a service partner, namely AVR, to do the glass collection from the roundabout 300 containers in the city and transport the glass into the nearby harbor of the city of Mannheim, from where they are shipped to the glass recycling facility. The containers for glass are shown in the upper picture here on the slide. They have 3 compartments for white, green and brown glass. For the scope of the project, we are only mounting sensors into the compartment for white glass, as it is proven to fill up first. Also, during the pilot, we have only 10 containers in scope. The other photo shows how the sensor is mounted on the top of the inside of the container. Camera perspective is looking upwards. Well, this actually brings us to the topic of what type of sensor to use here. And for this topic, SAP decided to partner with Pepper & Fuchs, who have 60 years of experience in manufacturing industrial sensors. Pepper & Fuchs runs its headquarters in the city of Mannheim, just a few kilometers away from Heidelberg. They are a large enterprise with 6,000 employees in many subsidiaries globally, which makes them a strategic partner for SAP for sensor technology. But let me hand it over to Michael and let him tell you more about Pepper & Fuchs and what type of sensors we are using in Heidelberg. Michael?
You're right, Frank. Well, as the sensor is a generator for condition information from the glass container, it needs to deliver reliable data for a very long period of time. Sensors are not all the same. There is a huge variety of sensors out in the market for all different kind of purposes. In a previous unit, we already learned about sensors as transducers for physical into electrical data. These kind of microchip-based sensors need to be integrated into a printed circuit board of a bigger thing, like a coffee machine, a fridge or a car. A better performance is provided by industrial sensors. These are standalone components which are ready to be connected to a machine-controlled system. For the use in our guided glass containers, there is even a higher level of self-reliance and robustness required. These sensors for outdoor purposes need to be water, dust and dirt proof. They should be resistant against shock and extreme temperature conditions. You may imagine how tough this could be for a small piece of electronics. Engineering, building and stressing electronic components is Pepper & Fuchs' domain. It used to manufacture industrial and outdoor sensors for decades. Therefore, it appears obvious that P&F also provides solution for several IoT verticals, like smart city, smart logistic, and smart industry, all with high requirements on reliable and robust sensors. Namely, these solutions are filling level, position and motion control, as well as track and trace applications. P&F's objective is to provide a high-quality source of data. The better the origin of data, the more reliable is the information as a base for prediction and further data analysis. This purpose was also, you could say, the founding father for the new development of the certain filling level sensor for Heidelberg. The result is an integrated ultrasonic sensor that measures the distance between the surface of the glass filling and the top of the container on an hourly basis. It is powered by battery and works up to 7 years autonomously. The collected sensor data is routinely transferred via LoRaWAN radio connection to the internet. As the IoT sensor is additionally equipped with a GPS module, it gives the actual geoposition of the container. The battery status and the measured temperature provide valuable information about the sensor itself and the actual environmental conditions of the container's side. Inside the device, there is an integrated electronic working, which allows to adjustment for the physics of measurement to the individual geometry of the container. Furthermore, the sensor is able to pre-process and consolidate the raw measuring data. Less, but better sensor data increase the payload efficiency and save bandwidth of the radio connection channel. Let's have a closer look at the radio connection between the sensor and the internet. Like many other cities, Heidelberg is currently rolling out a LoRa network. The partner for the installation is Smart City Solutions. They are experts on LoRa implementations for the public sector. LoRaWAN is a radio technology especially developed for IoT applications. It uses license and permission-free frequencies, which makes it very cost-efficient. It allows to transmit low data volumes over a range of up to 25 kilometers on very low energy consumption. This advantage allows long battery lifetime for IoT sensors. LoRa supports bidirectional communication and secures its data transfer by transport layer encryption. To date, Smart City Solutions already installed 2 LoRa antennas in Heidelberg. These deliver a decent reach of the LoRa signal for most of the glass containers within the city area.
So thanks, Michael. So we really see that the right sensor partner on board is really critical to the success of such a project. But let's look at it in a slightly more technical way. It all starts with the sensors in the recycling containers. The sensors send their encrypted payload via LoRa protocol to the nearest LoRa gateway. That's where protocol conversion happens, and the payload is forwarded via SSL to the central LoRa server. This is where payload is decrypted and sent as JSON messages securely via SSL to SAP Cloud Platform. Once the sensor data has been ingested into SAP Cloud Platform, we can process and respond to it. Our use case in Heidelberg is an example for a larger group of use cases that deal with monitoring fill levels of products, or in this case waste, stored in receptacles such as containers, tanks or silos that either run empty and need to be replenished, or, like in our case, run full and need to be emptied. That is, we are dealing with a standard enterprise scenario for which we can make use of the SAP Leonardo IoT ready-to-run application, in this case, SAP Connected Goods. You will learn more about these applications in future units, but for now, let me give you the basics of this scenario. As sensor data is getting ingested into SAP Connected Goods, we enrich the sensor data with business context, such as location details for each container and contact data for the responsible waste disposal contractor. As a next step, we evaluate enriched sensor data against a set of rules and then trigger not only notifications or emails, but a business response to the sensor data. Here we are creating a waste disposal order in the industry solution SAP Waste and Recycling. Alternatively, it could also be a ticket or a work order in an SAP or non-SAP system. So again, it's not just dashboarding sensor data, but it's real insight to action. Sensor data is responded to by triggering business processes in IT systems. Technically, it works via REST calls to CPI, Cloud Platform Integration, which connects the target business system and creates the relevant business object, in this case the waste disposal order, using the transmitted payload parameters. Future scenarios could use historic fill level trends to train machine learning algorithms and forecast when containers need to be emptied. This information can then be utilized for optimized route planning of the disposal vehicles. But let's conclude this learning unit with a quick demo.
So this is the SAP Connected Goods application, and we are looking here at live data from the sensors mounted into the 10 recycling containers. Each container is visualized as a tile here. So the view provides a dashboard of all live containers with recent KPI information like fill levels and location details. If you look here at the tile HD005, you may wonder why this small image shows a WASP. So this is to remember us that the team on site couldn't mount a sensor into this container yet because it's currently hosting a dangerous wasp's nest. So this is a type of unexpected surprises that can happen during an outdoor IoT project. So we can also switch into the map view. Here we see the container locations on a map of Heidelberg. We can also add an overlay with current fill level percentages of the containers. And we can also click on a container to get a tile again with key information about the container. And when we click on it, we can enter the detail view of this container. And as you see, we have enriched the data coming from the sensors with business context. For example, we have here location details and also contact information of the responsible waste disposal contractor. And from the GPS module, in the sensor, we are getting the current location of the container as shown on the map here. And below the map, we display a list of nearby containers. So the battery icon displays the charge level of the battery inside the sensor. The bold number is our key KPI, the current fill level. And then we have 3 charts. So the first one shows the time series of fill level in percent. And currently we selected an hourly view. And by the sudden drop here, this tells us that the container has been emptied only a day ago. And the second chart counts for each day the occurrences the sensor couldn't receive the ultrasonic echo and therefore couldn't measure the fill level in the container. And as you see, this happens quite rarely, which gives us good confidence into the sensor technology that we are using here. And on the bottom, you see a time series of the temperature, which a sensor is measuring as well. We also have an alert section here, and we see 2 active alerts. These are rule-based alerts. The first alert notifies us that the container has reached a high fill level and needs to be emptied. And the rule that triggered this alert also created in our industry solution SAP Waste and Recycling a waste disposal order for this container. And the second alert here on the top of the list is the most recent one and tells us that the container has been emptied. And the rule behind this alert looks out for patterns in the fill level time series like a sudden drop to recognize an emptying event. So this concludes the demo.
As you have seen, it often takes multiple partners to succeed in IoT projects. Thank you for watching and enjoy the rest of the course.